Leading a startup team, whether you're delivering a sugar rush, stocking coffee, or getting a regular delivery of snacks, Office Depot has solutions that fit every startup culture, from getting those first business cards and stationery to ordering fleece pullovers with your new logo. To learn how Office Depot and the California Technology Council have partnered to bring you savings on all of these startup essentials and more, go to californiatechnology.org/member benefits. I'm Daniel Levine, and this is the Bio Report.
There's growing scientific evidence suggesting that Alzheimer's disease may be an autoimmune condition. Whether it is or not may be an unsettled issue, but targeting neuroinflammation associated with the disease is viewed by some as a potential therapeutic strategy. INmune Bio is developing an experimental second-generation selective TNF inhibitor that targets neuroinflammation. It believes this approach can slow or stop the progression of cognitive and psychiatric symptoms associated with the disease. We spoke to RJ Tesi, CEO of INmune Bio, about whether Alzheimer's disease is an autoimmune condition, the role of neuroinflammation in the progress of the disease, and how his company's experimental therapy differs from existing TNF inhibitors today. RJ, thanks for joining us.
Thank you. It's a pleasure to be here. I look forward to telling you more about what we're doing.
Well, we're going to talk about immune neuroinflammation and your efforts to target this as a way to slow or halt the progression of cognitive and psychiatric symptoms in patients with Alzheimer's disease. Let's start with Alzheimer's disease itself, though. I'm sure most listeners have some familiarity with the condition, but perhaps you can begin with how the disease manifests itself and progresses, and what's the prognosis for patients today?
So, thank you. The Alzheimer's disease, everyone is very familiar with the problems with cognitive decline. That is that people begin to get a little forgetful, begin to do things like get lost when they go out to the grocery store, or as the disease progresses, they may not remember loved ones when they meet them. This is, the popular view of dementia and cognitive decline, and then, it's mild at first, and everybody thinks it's amusing, but as the disease progresses, it actually can become so severe that the person becomes a husk of their former self, with little interaction with the outside world or people around them. But there's another side to Alzheimer's disease that many people forget about, and that is the neuropsychiatric symptoms. That is to say, often the first manifestations of the disease, before the cognitive decline becomes difficult to manage, are problems such as sleep disorders, depression, hallucinations, apathy, and aggression or aggressiveness. And in fact, the most common reason someone takes a loved one to a physician where the diagnosis or the suspicion of Alzheimer's is entertained is for one of these neuropsychiatric symptoms, because they can really complicate the patient's interaction with those around them. And the bottom line is patients with Alzheimer's disease, as they slip down this slippery slope, require, help. They require care. They require a caregiver to really give much of their time to taking care of the care and feeding and safety of the loved one. So it's a difficult thing for everybody. Unfortunately, it's often difficult to diagnose early, or put it this way, since there's no effective therapies, there is little incentive to diagnose it early. That will change, we believe, in the future. And it's also impossible to know how quickly someone's going to slide from mild to moderate to severe. I can guarantee you that everyone goes through these phases, but some people may take 10 years, some people may take 5 years, some people may take 20 years. So it's a downhill slope, but everyone slides down the hill at a different rate.
How big a problem does Alzheimer's represent?
So there's 2 ways or 3 ways to look at it. As far as the actual number of patients, the number that the Alzheimer's Association figures is there's 5.8 million people with Alzheimer's disease in the United States. And if you add dementia, which is basically the same kind of cognitive decline, but maybe for reasons other than they don't have the amyloid pathology, there's probably about another 2 million or so. So you're talking 8 million patients or so, which may not sound to be a lot, but the impact of those 8 million patients on their families and caregivers is dramatic. So for every person with Alzheimer's disease, there's at least one other patient that is affected. That is the caregiver, and there's a whole set of pathology associated with the caregiver. And the economic impact and the economic cost of caring for patients with Alzheimer's disease far outstrips any other disease in the country. That is, we pay more for caring for Alzheimer's disease patients than we do for cancer patients, than we do for patients with cardiovascular disease, the psychiatric disease. It is a huge problem, and remember, it's an age-related problem. That is, the biggest risk factor for developing Alzheimer's disease is progressive age. And as you know, the tsunami of the baby boomers is rapidly approaching the age of risk. That is, once you're north of 70, the risk goes up demonstrably, and 1 in 3 patients older than 90 has some form of dementia. So, the more of us that get into those the 80s and 90s, the more patients, or the more of us are going to have evidence of dementia. And we need a solution to the problem. Not only are we going to need effective medicines to help potentially slow the problem, we're going to need the infrastructure in place, physicians and clinic systems to help care for the patients, and we're going to need places for these people for all of us to live. So it's a big, big problem.
We've seen a large number of late-stage failures in clinical trials of experimental therapies. What's been the general approach in targeting the disease and new therapies, and why do you think we've had so many late-stage failures?
Yeah, so I think there's 2 reasons. First of all, the initial target was wrong. That is, amyloid plaques have been the popular target in academia and by biopharma for the last 20 years. And it became literally dogma that amyloid plaques were the cause of dementia and Alzheimer's disease, and that if you eliminated amyloid plaques, you would treat the disease. Now, to be sure, the animal data was not super convincing. It was sort of in the eye of the beholder. But as you know, when you get a bunch of groupthink going along, everybody, looked at this and they decided to interpret the data that if you got rid of plaques, you would cure Alzheimer's disease. And companies, now there have been a total of at least 5 major trials of large numbers of patients with multi-million dollars worth of clinical trial dollars, probably billions of dollars have been spent, and they've all been a failure. So one of the reasons, as I said, is the wrong target. It's just think about it this way. If you've got a car sitting in the garage and it has a dead battery, and you go and try to start the car and you go, I think it needs more gas, and you fill up the gas, and you try to start the car, it still won't start. You say, well, I need new tires. Well, I'm going to put on new tires. it still doesn't make the car start because, damn it, you got a dead battery. And that's the same problem we had with Alzheimer's disease. The other problem, I think, is there's been a lack of, shall we say, modernization or innovation in the way clinical trials have been performed. In many ways, all we need to do is look to the success of the development of oncology drugs. You know, the number of drugs that have been approved for the treatment of cancer over the last 10 years is quite impressive. And it's quite impressive for two reasons. First of all, there's a diversity of scientific and medical approaches to treating cancer. As I already mentioned, there was only one approach in Alzheimer's disease. That was amyloid, and it turns out to be wrong. But the more important strategy is they use what's called a precision medicine approach or a biomarker-adjusted approach. In other words, they made the assumption that just because you had, let's call it breast cancer, it didn't mean all patients had exactly the same type of breast cancer. For instance, we know there's hormone-positive breast cancer and HER2-positive breast cancer. Those cancers are treated very differently. On the other hand, with Alzheimer's disease, the assumption was made that everybody had the same disease. And it would be, in retrospect, it was shocking to think that a disease that was described in 1905, that's 115 years ago, that description would be precise enough to guide drug development, 100 years later. And in fact, it hasn't been enough. We believe there, just like in cancer, just like in breast cancer, where there are multiple diseases, shall we say, it's all breast cancer, but there's multiple types of breast cancer. We believe there's multiple types of Alzheimer's disease, multiple causes. So what we need to do is do exactly like they do in cancer, where make sure that we know exactly how our drug works, and then we pick the patients that have the disease that matches up with the mechanism of action of our drug. That's called precision medicine, and we like to think at INmune Bio that we're on the cusp of, or in the forefront of that trend of using a biomarker-directed precision medicine approach in the development of our drugs for Alzheimer's disease.
You're developing a TNF inhibitor to treat Alzheimer's. TNF inhibitors have been generally used to treat autoimmune conditions. Does this suggest Alzheimer's is an immunological condition? Do you think you're treating an underlying cause with this approach, or is it a symptom?
Yeah, so I think you bring up a good point. So we do view that there is an immunologic component to Alzheimer's disease. Now, I'm not going to get into a deep discussion about whether it's the most important element of the disease or an important element of a disease. But one thing is for sure, patients with Alzheimer's disease have what's called activated microglial cells. Microglial cells are immune cells that are resident in the brain. They're important for the care and feeding of many of the cells of the brain. And when they get activated, they usually cause mischief. That is to say, they were designed to prevent infection in the brain, but they're actually doing something worse. They're developing something we call chronic inflammation, and they're dysfunctional for a long time, and that dysfunction results in nerve cell death and synaptic function. So yes, neuroinflammation or chronic inflammation of the brain is an important part of the pathology of Alzheimer's disease. Now, where does this inflammation come from? Well, that's a bit of a incompletely answered question, but we have some of the answers. There's no question that some of the causes are epigenetic and genetic. There's a gene called ApoE4, which many people have. It occurs in somewhere around 20% of the patients, or 20% of the people. These people have an increased risk of Alzheimer's disease, and it turns out that one of the things this gene does is it makes the immune system more active, a little hyperactive. I guess that's one way to do it. Another thing is to look at what, let's call it, biologic issues. And as I already mentioned, the biggest risk factor for Alzheimer's disease is advanced age. You know, people don't get Alzheimer's disease when they're 20, 30, 40, 50 for all practical purposes. It starts coming when you're older. So age is important. And there are also both environmental and behavioral triggers. You know, if you happen to, you know, eat a lot and sit on the couch and don't exercise, have type 2 diabetes, you have a higher risk of developing neuroinflammation than someone who is a marathoner who doesn't own a TV. So, you know, there's a lot of reasons why we develop neuroinflammation. Some are directly related to genes. Some are related to what's going on in our lives. And some are just because we're getting old. But all of those things to contribute to the microglial cell becoming angry and starting to kill nerve cells and causing synapses to disconnect.
There are plenty of TNF inhibitors on the market today used to treat autoimmune conditions. What is your experimental therapy X-Pro 1595, and how does it differ from TNF inhibitors that exist today?
Well, the difference is night and day. There's no question that the first generation TNF inhibitors that are on the market today, we call them non-selective TNF inhibitors, have revolutionized the care of autoimmune disease. Like diseases like rheumatoid arthritis, Crohn's disease, ankylosing spondylitis, and psoriasis. These patients have benefited mightily from these drugs. The problem with them is they're, you know, just think about, you know, they're kind of like a, I don't want to say a Model T, but they're like a 1955 automobile. They do the job, they do it well, but, you know, if you're thinking about, you know, going far and fast, they may not be the best choice. So our drug is a TNF inhibitor, but it's very different. It's a second generation TNF inhibitor that only targets the bad TNF. That is to say, there are two types of TNF. There's the bad TNF, which causes inflammation and causes the things like autoimmune disease, microglial activation, nerve cell death, and synaptic dysfunction. And then there's something called the good TNF, which is transmembrane TNF, which actually promotes remyelination, is neuroprotective, and actually promotes immune function. The good TNF you don't want to block, especially when you're treating diseases of the brain. In fact, the current TNF inhibitors will make neurologic diseases worse because they actually affect something called the remyelination or demyelination. Myelin is the insulation around the nerves. It prevents them from shorting out when they are running in bundles. And as you can imagine, if you were to strip off the insulation on a bunch of wires and they start shorting out, that's not a good thing. We won't be able to hear each other talk on the phone. So when you treat patients with neurologic disease with the non-selective TNF inhibitors, you actually can make them worse because the drug is targeting, it's an off-target effect of the bad TNF. X-Pro 1595, the second generation designer drug, only targets bad TNF, does not target the good TNF. In fact, it improves the function of everything related to the good TNF, including remyelination. So it's a TNF inhibitor, but it's a very different type of TNF inhibitor, and it's specifically designed, it is ideal for the use in neurologic diseases.
You dosed your first patient in a phase 1b study in December. What's the design of the study, and what will you be looking at beyond the necessary dose?
We've already completed a phase 1 trial in patients with cancer with the drug, but we're now moving into Alzheimer's disease. And as you might expect, the average age of patients with Alzheimer's disease is significantly higher than patients with cancer. And so that the phase 1 trial in Alzheimer's disease, which is supported by a Part the Cloud Award from the Alzheimer's Association, is moving along well. But it does have a very novel design. And once again, I reiterate that this design looks more like a cancer trial than a neurologic trial. That is to say, some companies, when they see 10 patients with Alzheimer's disease, and they say, okay, we're going to enroll all 10 of those in our phase 1 trial. That's not the way we do it. That's not the way you would do a cancer trial. Remember, we want to choose the patients that have neuroinflammation as a cause of their disease, and those are the ones we want to treat. So we line up 10 patients and we go, well, how many of you patients actually have neuroinflammation? And it turns out 3 or 4 do. So we select those patients that have neuroinflammation, and those are the ones we study in our trial. Now, the phase 1 trial is not overly ambitious. The purpose of the phase 1 trial is to prove that we have controlled neuroinflammation. It's a 3-month trial. It's short. It's open label. We have multiple ways we can measure neuroinflammation, and our goal is to decrease neuroinflammation. It is not to improve cognition or change the decline of cognition, which is what the goal of a true Alzheimer's trial is. All of the patients have Alzheimer's. All of the patients have neuroinflammation. And the goal in the first 3 months is to prove neuroinflammation. Once we prove we get rid of neuroinflammation, we then do a larger, longer phase 2 trial, 18 months versus 3 months. And in that trial, we expect to demonstrate that we improve cognition or improve cognitive decline. So it's a 2-step process. It's a process that allows us to make sure that we don't, shall we say, we're not swinging for the fences. We're not trying to hit a home run. The first clinical trial is a single. The second clinical trial will be a double. And the third clinical trial will be a in the park home run. So,
and what's known about the drug to date?
Quite a bit. I mean, this drug has been available for use by academics in basic research and animal studies for, more than 10 years. We have over 60 publications on our website, which is, I've never heard of a company with that many publications. We know a lot about the drug. And as I mentioned, it's already been in man for the treatment of a phase 1 trial in malignancy, and we'll be using it to treat other patients. So, in some ways it's kind of convenient and easy to start a clinical trial with the drug because since we know so much about the first generation TNF inhibitors, that experience informs us about how we should move forward with this novel second generation TNF inhibitor. And in fact, we expect, it needs to be proven in man, but certainly in animal studies, there are many advantages and improved safety of the second generation drug compared to the first generation drug. So we are quite confident that as we move through these clinical trials, that there will be benefits to the patients.
And what's the development path forward and the timing from here?
So the phase 1 trial should read out in October. That's our goal. And for after that, in Alzheimer's disease, assuming we have a positive trial in 2021, we would expect to be initiating a phase 2 trial. But, the drug has uses beyond Alzheimer's disease in neurodegenerative diseases. Just last week, we received notification that we received a $500,000 grant from the ALS Foundation to study the drug in preclinical models of ALS, which, as you know, is a devastating disease. And the purpose of that funding is to prepare us for a clinical trial in the future. We have had funding from MJ Fox Foundation in the past for Parkinson's disease research. This drug has a very interesting applications in Parkinson's disease, and we would hope to be able to pursue Parkinson's disease studies in the future. So we believe the future is bright for this drug in the neurologic diseases. The first data in man will be in Alzheimer's disease, but by no means will that be the last data.
As you look down the road, do you think this, as we've seen in cancer with combination therapies, that this might be an important part of a combination approach to treating these neurological conditions?
Yeah, I think that's a very insightful comment. These are complex diseases. We don't see any silver bullets out there for the most part. We think if you look at how cardiovascular disease and cancer and many diseases are treated, they're treated with combination therapy. And we believe that actually that will be the same for Alzheimer's disease. We think that we are well positioned for that because almost any mechanism that you attribute to Alzheimer's disease, whether it be amyloid or tau, i.e. misfolded proteins, whether it be lysosomal dysfunction, mitochondrial disease, neuroinflammation plays a role. So we think that no matter how you're going to go after Alzheimer's disease, you're also going to have to cool off the brain because neuroinflammation is problematic. And to do that, you need a drug that is effective and it has to be safe. In other words, it cannot come with its own set of safety problems. Because if you combine two drugs, the chance of you having safety issues increases. In our case, we bring something that is not only safe, it may actually make some of these other drugs safer. So we think at the end of the day, we will be a favorite partner for many of these combination therapies. Patients will benefit, and obviously INmune Bio and its investors will benefit.
RJ Tesi, CEO and Chief Medical Officer of INmune Bio. RJ, thanks for your time today.
Super. Thanks.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.